Hello, and on behalf of our Research Institute, I'd like to welcome you all here today for our presentation on vulnerability management in cybersecurity. So who are we again? We are a research institute focusing on artificial intelligence and cybersecurity. You are Mark Chaplin, the UK Principal at Information Security Forum, the ISF. You have over 30 years in experience at cybersecurity. The ISF is a trusted, not-for-profit platform that provides best practices, processes, and solutions in information security and risk management. So our goal today is to advise you, the ISF, that you should recommend members to use machine learning algorithms to better prioritize remediation of vulnerabilities in your best practices guide. So why are vulnerabilities a problem? As you can see clearly in this graph, the number of vulnerability disclosures by companies per year has been increasing, especially in the last couple of years. As you can see, in 2018 alone, there were over 15,000 vulnerability disclosures. This is over double that of 2016. Clearly, in the past couple of years, something has gone wrong in this industry. So let's take a closer look at the problems which a lot of industries face. So as we already know, an asset might have a flaw. This is called a vulnerability. An attacker might attack this flaw using a designated tool in order to exploit it. And then the answer to this is currently remediation. In many cases, this means updating a security patch to close the security flaw. So now that we've understood the problem, we can now look at vulnerability management today. So with the growing number of vulnerabilities disclosed, it is challenging for companies to prioritize one over another. As we know, the basic process of vulnerability management includes, first of all, knowing all your IT assets and networks and looking actively for problems in them, prioritizing them, and finally applying the solution. Our ML solution deals with the prioritization stage, seen here in red, mainly because there lays the greatest potential for ML and because, as we will show, prioritizing is a big problem. So to illustrate the difficulty of prioritization, we're going to use the game of whack-a-mole. Imagine you're playing whack-a-mole, but this time you're not facing 5, but 1,000 holes that from any time could pop up at any given moment a mole that you need to whack. As you only have a single hammer, how could you prioritize which one to whack first? This is the problem which a lot of companies in these industries face. So at the moment, the current remediation process is flawed. Basically, each vulnerability is given by an industry a score of 0 to 10. This calculates the general impacts of the vulnerability and the general easiness of exploiting it. So what's the problem? Typically, companies choose one score that everything with it or above will be patched. But the score doesn't calculate the importance of your relevant asset. And even worse, as you can see in the vulnerability distribution graph on the right, you're left with the choice of having an unimaginable to-do list or risk that you'll miss the next mega attack because your threshold was too high. And this isn't just theory. Two of the most devastating cyber attacks, WannaCry and Petya, of the last few years could actually have been avoided as the security patch was released 2 months before the attacks occurred. Companies just miscalculated. And as the number of vulnerabilities is increasing each year, as we've showed previously, this was only going to get worse. So the industry itself also recognizes that the current solution is flawed and that there are just too many vulnerabilities to cope with effectively. As we can see here from the Kenneth Security Report, the bottom graph shows that there were too many vulnerabilities with no way to effectively prioritize. This is the same problem which led to the last 2 attacks which we just talked about, which cost the NHS £92 million and FedEx and Maersk over $300 million each. So the solution to this problem that we propose to you today is that of machine learning. So how can ML help? A machine learning model can be extremely useful in classifying vulnerabilities and providing predictions about the vulnerabilities that need to be patched. Specifically, there are 2 questions which ML models seek to address. The first is, will this vulnerability have an exploit written for it? And will the exploit to be developed for a particular vulnerability be used in an attack? So to answer these questions, we're going to look at the technical details of the first iteration of the machine learning model. As you can see in step 1, the first iteration of the model ingests a company's specific asset data, global threats, and information from vulnerability scanners as training data. However, the input data is selected based on volume and velocity of the vulnerabilities, as outlined in step 2. A binary classification model, outlined in step 3, is used to generate a yes or no answer. This output predicts whether an exploit will be developed for a particular software or vulnerability. This prediction is then sent to the second iteration of the model. The second iteration of the model uses a rainforest classification model. It predicts more than just the yes or no. It further narrows down and predicts if the exploit actually has chances of being used in an attack. It does this in step 1 by limiting the training data to vulnerabilities that have exploits. Then it limits input data to vulnerabilities that are predicted to have exploits developed for them. This output is crucial to generate a risk score for the vulnerability. Higher risk scores indicate immediate attention for patching, as seen in the diagram below. So to elaborate further, what exactly is the classification model we just mentioned? It's a supervised machine learning model that draws conclusions from observed values. In a given context, the model draws discrete conclusions from assets, threat, and vulnerability data. More so, precision and accuracy are two crucial benchmarks for any machine learning model. In this case, precision, that the exploit is correct, is more valuable information for businesses than accuracy of number of vulnerabilities detected. So a question arises. Why do we need a predictive risk-based, data-driven and vulnerability solution when existing CVSS score-based systems suffice? The answer is to move away from manual error-prone Excel sheets, scanning towards a robust automated approach. Also, the current approach of let's just patch vulnerabilities with CVSS scores of 7 and above misses out real-time threats and thereby resulting in breaches. So to show you the improvements that can be gained from using an ML approach, we've chosen Cybersecurity as our use case. Although we do not recommend one company over another, we believe that Cybersecurity is an ideal use case to show the extent that ML can help a business. So to begin, who is Cybersecurity? Cybersecurity is a leader in predictive cyber risk. Its new machine learning solution was created in 2017, Cybersecurity's Exploit Prediction. It was piloted on 12 companies across different industries in 2017. So how does exploit prediction work, and how does it link to the technical details we just talked about previously? Well, the ML system mines Cybersecurity's ground truth telemetry, which is a database of 2 billion vulnerabilities, for real-time insights on attacker behavior. Then a predictive modeling algorithm forecasts the likelihood of exploits being weaponized. Lastly, a risk scoring engine forecasts the risks of new vulnerabilities. This then allows companies to see which of these vulnerabilities need to be prioritized. So to show you the extent which ML can transform a company's vulnerability management, we've chosen 2 other companies which have partnered with Cybersecurity. The first of these is TransUnion. It's a global leader in credit protection that specializes in helping organizations optimize their risk-based decisions. Specifically, it had 2 problems before it partnered with Cybersecurity. The first of these was department coordination. Basically, the security ops team wants to patch everything, and the IT ops team wants to know which patches made a difference. Secondly, it had a technological problem, specifically inefficient tools. As the CISO of TransUnion states, people were spending more time managing pivot tables than the actual vulnerabilities. So the solution to this vulnerability management problem was prioritization using machine learning. This had 2 very significant outcomes for TransUnion. The first of which was less friction between the security and the IT teams. This is because ML prioritized the most critical vulnerabilities and showed the reduction of risk as a result of patching and remediation. The second result was that the teams agreed on most immediate vulnerabilities to patch and avoided the use of pivot tables. This led to greater efficiencies as all the teams worked from a single source of truth. So Genpact is the second company which Cybersecurity helped. Even though it's in a different industry, that of professional services, to TransUnion, the result was the same. It had a huge success using machine learning. The problems were very similar too. It also had inefficient tools, as Genpact had a huge legacy system of 70,000 assets across several data centers. Equally, just like TransUnion, it had a team for ranking vulnerabilities and used an excess of Excel sheets, which would often take days to reduce overall vulnerabilities. As the assistant vice president of the company states, our remediation approach involves sifting through enormous spreadsheets. So again, the solution was to prioritize using machine learning. The results were just as effective as they were in the TransUnion case. Efficiency rose greatly after the Excel sheets were decreased. As the vice president of Genpact stated again, remediation teams were able to focus their efforts on the most impactful actions that can significantly reduce risk versus running on the treadmill and not making any real progress. This is the impact that ML can have on a business. So now taking a step back and looking at the macro view of what Kenna was able to do with ML. So to begin, there is a 92% accuracy rate using exploit prediction when forecasting weaponization of new vulnerabilities. Next, over 80% of Kenna's customers reduced their risk posture score by 25% or more. In fact, The Economist even reduced theirs by over 50% since their implementation in 2018. What can we gather from all of these use case results? So the benefits that we've just mentioned are significant, beginning with increased remediation efficiency and maximizing remediation coverage. Equally, these two approaches can offer operational efficiencies and potential operating expense savings on the medium to long term. Overall, these two approaches would help to reduce time on consuming and complex manual inspection and intervention processes, and this is what we saw in the use cases where efficiency was maximized overall. So in sum, our recommendations to you at the ISF are as follows. First, we believe that ML is a better tool to prioritize vulnerability in compared to alternatives. Hence, the use of machine learning algorithms should be considered positively to prioritize vulnerabilities effectively. Second, to provide input data, companies should be guided as a precondition to maximize their ability to A, identify their systems and networks, and B, scan actively for vulnerabilities within them. Next, because of the complexity of the use of ML, it should be strongly considered that external providers would be used for the prediction stage. On the other hand, the ISF should be wary not to promote one product in order to prevent monopolization of the market. Lastly, although ML is a good solution for the prioritizing problem, of course it's not a magic trick for the entire vulnerability management process. Companies will still need to cope with the rest of the challenges. For example, once a company has prioritized, how do they manage the patching process itself in relation to the business process? So lastly, to give you a balanced view of machine learning, both the positives and negatives, we've identified a few challenges in recommending machine learning. So here is our risk assessment. Firstly, we'd like to draw your attention to the first line. The risk scenario is lack of appropriate data input. We rate this impact high. Specifically, as we just mentioned, companies must mitigate this by maximizing their ability to identify systems and networks and scan actively for vulnerabilities within them. Secondly, we would like to draw your attention to the probability that a lack of understanding of machine learning and cybersecurity in companies could be a problem. We rate this again a high impact and a high risk, and as such we would mitigate this by recommending and considering that external providers would be used by these companies. Our last risk scenario that we'd like to point out to you is the potential that decision makers can disapprove of the project. Yet again, we rate this a high impact and a medium risk. And our mitigation recommendations or the business advantages of ML should be clearly articulated, explaining both the high risk of unpatched systems and the alternatives, as is clearly done by the chief security officers in both the use cases we've examined. So on behalf of the Artificial Intelligence and Cybersecurity Research Institute, I would like to thank you for your time. We hope today that we've made a compelling case for your members to include machine learning as part of their vulnerability management as part of your best practice guide. Thank you.